Hi guys, welcome to our channel of Sciences and Mathematics. Topic of discussion for today is going to be under the statistical treatment of data. Of course, this is just a field in analytical methods or analytical chemistry, but we're going to see that there's different ways in which we can be able to express the uncertainties that we find due to measurements. And especially we're going to learn about the concept of accuracy and how maybe the data can deviate from the true value or maybe the expected value. So for this case, thank you and welcome. So as I've said, we're going to look at a method that is used in or a term that is used in statistical treatment of data. And that is the concept of accuracy. Accuracy, of course, appears in different areas, especially in the introductory part of most of the sciences like mathematics, physics, and even in chemistry. So in this case, in statistical or analytical methods, we're going to see that the term accuracy still pertains to the same concept that this is a measure of how close a value is to the true value. So in this case, we have a value that is a measured value, and then we have what we call a true value. And whenever we are doing measurements, of course, we see that we cannot do a measurement and attain 100% accuracy. So we cannot attain the true value of a measurement, and therefore the inaccuracies that occurs in between this process of measurement is what we call errors. So errors basically refers to the inaccuracies. This is inaccuracies that of course comes or realized due to the process of measurement. So in this case, as we have said about the concept of accuracy, and error stems from accuracy in a sense that we cannot be able to obtain a measurement to its absolute or to its just accuracy of 100%. So therefore, there's going to be a deviation from the true value, which is going to give us uncertainty, so that we have referred to as errors. So in this case, of course, we are going to denote experimental values from the measurements that we do using, of course, this set of registered denotation. Therefore, during an experiment, when we are trying to collect data from an experiment, we have what we call an experimental value, of course, which is denoted as xi. Therefore, for our examples that we are going to do for this, we are going to denote our experimental values using that one. And then I've talked about the true value, which is a value that is expected from a measurement. And this one is going, of course, this is a true value. We just write it in full, which is going to be denoted as m. And therefore, the deviation from the true value of an experimental value is what we call an error. So therefore, this basically, we are going to refer to it as an absolute error. In some of our methods, we've talked about the concept of absolute value. So in this case, we're going to talk about an absolute error. So therefore, an absolute error can be represented as the deviation from the true value. It's a true value, and then that's a value of experimental value of measurement. Now that it's absolute, it can be either ways. It can be represented as the measured value, of course, minus the true value, or either ways. So in this case, of course, if we have achieved a mean, which is a representative of a value, we can give the absolute error still as the mean minus the true value. So that's going to give us absolute error. And this is a way in which we can be able to express an inaccuracy during statistical treatment of data. So in this case, the use of absolute error sometimes may not give us to its, or may not lead us to a convenient way of trying to determine the true value. Now that we have written this equation for it, so in this case, of course, we are going to use a different way to describe the error in relation to the magnitude of the true value. So this way of expressing is going to be a relative error. Now that we have said this, the first strategy might not give us a convenient way in which we're going to determine the true value. Therefore, a substitute for that is a relative error, which of course is going to give us or will describe the error in relation to the magnitude of a true value. And the relative error can be expressed in two different ways. That is, it can be expressed as a percentage or as this is known as parts per thousand. So this is parts per thousand. So in this case, which is a convenient substitute for this first one, relative error can be expressed as a percentage or parts per thousand. So therefore, we are going to have an expression for that, since that we have said this error is a ratio or a deviation from the true value. So we are going to have relative error given as absolute value divided by the true value. So now that we have given an absolute value using the different ways there. So this is the first way in which it can be expressed. Of course, we have said as a percentage, and therefore we can just write it as a relative or a relative percentage error can be expressed as absolute error. We just use these initials just because of we've already written them over true value. So expressing this one as a percentage, of course this is a ratio, it's going to be times 100. So the answer we get this one is in the form of a percentage, maybe X%, or maybe it can be expressed in forms of parts per thousand, which of course is going to be given by doing an multiplication of this value. So in this case, I'm going to use a sample question in trying to illustrate on how we can be able to find absolute error, or different ways in which we can be able to express the absolute error or the variation or the inaccuracies that we've discussed. Of course, this is going to pertain to the concept of, I've talked about the mean. So this is going to pertain to the concept of the mean, which of course we shall derive from other strategies or methods of the statistical treatment, especially the measure of the central tendency that we have discussed in one of our videos on statistics. So therefore that is going to entail the mean. Given our data, we're going to find the mean and the median, and then we are going to use the two strategies in trying to find the absolute relative error. So in that case, I'm going to write that question on the board, and then we are going to solve it. So that sample question is going to assist us to work on how to find the mean absolute error and the mean relative error in forms of percentage and parts per thousand. So in that case, we are going to just go through the question. It states that calculate the percentage error and parts per thousand error for an ion analysis that gives the following set when the true value is set at 8.27 milligrams. So this set of data is given above. So therefore, first we are going to try to identify or use the set of data in order to find what we call the mid-low numerical value, and that is the middle numerical value, that's the median in alphabetical in arithmetical order. So we're just going to try and do an rearrangement of that set of data, and we'll find that we have 8.28. So we just arrange that one in ascending orders: 8.28, 8.29, and then we have 8.33, and then we have 8.34, and lastly we have 8.36. So in this case, of course, if we try to look at that in a arithmetic order, our medium or middle numerical value is going to be 8.33, Therefore, this is going to make our median 8.33. This is going to make our median. And from the concept that we have learned in some of our videos about how we can derive a mean, mean is the summation of all the figures divided by the summation of frequency. So in this case, for the data that we have, range of data that we have given, we're going to find that the mean is a summation of all these figures divided by the frequency, which is of course 1, 2, 3, 4, 5 divided by 5. So this is going to give us, if we do a calculation, 8.32. Therefore, this is going to give us the mean. So now that we have found the mean and the median, the mean absolute error can be expressed using these two sets of concepts by finding the difference between the median and the true value. So we have gotten the median to be 8.33 and the true value as 8.27. The difference between the two is going to give us the mean absolute error. The mean absolute error is the difference between the median and the true value. So therefore, this is going to, of course, give us, this is just a subtraction 3, 0.0. This is just to do a subtraction for this 8.33, 8.27. This is a 6. This is a 0.06. That is going to be the mean absolute value. And the mean relative error is going to be, of course, expressed. So just trying to confirm my calculations. This basically is going to be 2. That is for the mean. I just confused the mean. This is going to be the mean that is going to be there. So for that case, it's going to be, of course, this one gives us absolute error. The mean relative error is going to be the difference between this mean and the true value. So for that case, the mean relative error is going to be, this is the mean and the true value that we had written in one of the equations. So it's going to give us 0.05. So expressed as a percentage, we're going to give that one over the true value times 100. So basically for that one, the mean relative error is going to be 0.60%. So of course this is going to be 0.646%. I've just given it to just two decimal places. So therefore, now that you have described the mean absolute error and the mean relative error in form of percentage, we were also required to express this one in terms of parts per thousand. So I just do away with the first bit of this one so that we can be able to see how to express it. So the mean relative parts per thousand error is going to be given as the mean relative error, which was 0.05 over the true value 7 times 1,000. So that one is going to give us 6.046 parts per thousand. So this is how we can be able to express those values for a range of data that we have been given in this ion analysis. So in this case, of course, the concept of the accuracy and absolute error are very basic, because this is going to give us the difference between, or the level of accuracy in which we have done an experiment which is going to assist us in trying to interpret the data and get the relevant information that we require during an experiment. So in this case, we're going to stop there. I hope this concept has been understood, and we're going to apply it in different areas that may be required, or maybe the concept of accuracy and absolute error, or error, the parts per thousand error, whenever we may be asked. So for that case, that is it. Bye for today.